All right, we're live. Okay, guys, we are getting close. Can you guys see that better now without that glare? Yeah, that works out. Okay. We're getting close to the end of the year. Just so you guys know, today and then the next Tuesday. So we have today and next Tuesday are the last days of the school year for everybody, I think. The last week there will be no lesson from me or any of your other teachers. At least that's what I heard. Okay. We have 2 concepts left to learn. Today we're going to do chords. Last week we spent the whole class learning about tangents and their relationship to circles. Now we're going to do chords. Now, unlike last week, I'm not going to write down all of the theorems in the section of the book. This is all in section 10.3. So if you have your book, you can find all these theorems in 10.3. And these are the theorems that relate chords to circles. Okay, what is a chord? Just to recap, a chord is a line segment that goes from one edge of the circle to the other. So this is a chord. The longest chord of the circle is the diameter. All right. So let's just talk about 2 theorems, and I'm going to summarize the theorems. I'm not going to go into great detail on them. The 2 theorems are basically this. If the chords are congruent, the arcs are congruent. And if the chords are congruent, the angles are congruent. So let's look at this chord and we'll name it AB. Chord AB. Okay, here's the center of the circle. I'll call that C. Okay, if I have another chord, and it doesn't have to be parallel. Okay. All right, so here we know that all of these are congruent because they are all radii of the same circle. They go from the center to the edge, so all of those are congruent. All right, the first theorem says that if these 2 chords are congruent, this one and this one, then their arcs must also be congruent, which means that this arc is congruent to this arc. All right, that's what that theorem says. And there's a converse to that theorem that says if this arc is congruent to this arc, then the chords that make the arcs must also be congruent. All right, that's the arc theorem. Or the chord arc theorem. I don't know the name of it. The chord angle theorem says that if this chord is congruent to this chord, then their central angles must also be congruent. This angle is congruent to this angle. We'll call it D, E. So, if AB is congruent to DE, then angle ACB must be congruent to DCE. All right. And the converse of that. If this angle is congruent to this angle, then their chords are also congruent. All right. Any questions so far? All right. I just saved us like 20 minutes of explanation. So now there's another theorem we got to look at. You know what? Yeah. Erase all this. The third theorem says this is the diameter. Let me just double check. I don't want to say it wrong. Okay. If the diameter is perpendicular to a chord, then it bisects that chord. And that could be any chord. If this is perpendicular, then this is congruent to that. All right? And vice versa. If this is congruent to that, then the chord has to be perpendicular to its bisector, which is the diameter. Okay, last thing. If we have a chord and a chord, here's our center. If this is congruent to this, and these are perpendicular, if these are perpendicular and these two lines are congruent, then the chords are also congruent. So we would say that AB is congruent to CD. AB is congruent to CD. And vice versa. If these are congruent, then that means the line going from the center perpendicular to them they're also congruent. Okay? That's all the prerequisite information we need to know for what we're going to do. Do we have any questions before I move on? Okay. Now, I gave you guys an attachment on the Google Classroom. Make sure you have that open because those are the problems I'm going to be working from. It looks like it's labeled screenshot. It's the I gave it to you guys at 2 o'clock today. It's an attachment that says screenshot. Open that up. If you don't have it open, you can open it later or whatever you want to do. Oh, you know what? Before we get into that attachment, leave it open on a separate page or a separate tab or whatever. Before we get into that, I want to show you one thing. Let's say we want to inscribe an equilateral or equal length sided figure inside of this, like a square or a quad or a hexagon or a triangle, anything that has the same side lengths all the way around. All right, so how would you do that by hand? I'm just going to show you. So I'm going to show you using a triangle, and then it scales up to any figure. Okay, it could be a square, it could be a pentagon, a hexagon, an octagon. Any figure with the same side lengths can be inscribed in the circle using the same method. So the first thing you want to do is you want to measure on your, you don't have to do this right now because online you just have to describe it. But basically you want to measure the radius on your compass. So here's your compass. Okay. So measure the radius on your compass, okay? And then you're going to use that compass to create a circle, okay? So you're going to create a circle with your compass. And that circle is going to intersect this in 2 spots. Wait a second. What am I doing wrong here? I'm doing something wrong. Let me look at it. I actually haven't done this by hand since last year, so let me look at it. This is on page 439. Set the compass to radius of the circle, place the compass at point Q, and draw an arc. Oh, I see. Let's see, that would be keep the compass, all right. All right, well, I'm just going to show you how to do the one with the square. I don't really know how to do the one with the triangle, which is all right, I guess. All right, so here's how you make a square inside of a circle. You draw your circle, and then you draw the diameter, and then you draw the diameter perpendicular to that, and then you have your 4 sides. I don't know why you would have to do it this long way, they were saying. All right, you know what? Just ignore that. It's not important. We're just going to waste time doing this. I will give you guys the answer to that one for the homework because I don't feel like even dealing with it. All right, let's move on. Don't worry about the construction. There's only one problem on your homework and I'll give you the answer for it. All right, so we're looking at number 1 on the handout I posted on Google Classroom. We're going to do 1, 2, 3, and 4 is all on the same figure. So in black, I'm drawing the given information. Okay, and it's telling us that the angle of BAD and M and the measure of, all right, BAD is 90 degrees. And BC is equal to FE. Okay. Anything else given? Arc EG is 90 degrees. Okay. So that's the given information. Now it wants us to find 4 things here. The first thing is to find the measure of EAG. EAG. The measure of EAG is 90 degrees because its corresponding arc is 90 degrees. That's number one. Number two. It's asking us to find arc BD. That's this arc here. Okay, this arc is also 90 degrees. It has nothing to do with this triangle down here. It has to do with this angle here. If this is 90 degrees, then its arc is 90 degrees. So the measure of arc BD is 90 degrees because of this angle here. Okay, number three. We're gonna move through this pretty quick this week. Which angle is congruent to BAC? So what angle is congruent to BAC? Well, you might think that CAD is congruent, but that's only if this is 45 degrees, and we don't know that. It's not telling us that these two are perpendicular, so we don't know that. However, we do know that this chord is congruent with this chord. And the theorem we learned earlier in this lesson is that if two chords are congruent, then their arc measures are congruent. And if two chords are congruent, then their angles are congruent. So the only one we can know for sure is congruent is this one right here. EAF. Because they have the same congruent chords. EAF, I'm sorry. EAF. I feel like I'm moving really fast. Am I losing anybody? Are you guys okay? Give me like a thumbs up or something. Okay, you're good? Alright. This stuff is pretty straightforward. Okay. The next problem, number 4. Which segment is congruent to BD? Now, this one is like, we have to use a little bit of thinking. Which segment is congruent to this chord? Well, it just looks like this chord, but we need to make sure. All right, this is 90 degrees, right? BAD is 90 degrees. How many degrees is EAG? It's 90 because it's got an arc of 90 degrees. So we know that this is 90, right? So if this is 90 and this is 90, then their chords are also 90. So EG is the same as BD, or is congruent to BD. So which segment is congruent to BD? We would say EG. Okay. That's it for that circle. Any questions? Thank you for the one person responding. All right. Let's look at number 5 and 6. Those have a different type of circle. JM N Okay, before I even answer the questions, we need to understand what's going on here. Firstly, these two distances from N are the same, so therefore the chords are congruent. Did I go over that theorem? Yeah, I did. All right. If the distance from the center of the circle is the same and they are at 90 degrees, that means that they are congruent and that they are bisected by the these points bisect the two chords. All right, so not only are these two chords congruent, but these things are bisected. From that information, we know that this is 15, this is 15, this is 15. Okay, and I think that's all we need to know for this question. Okay, so it says find JM, number 5. JM equals 30. 15 plus 15 is 30. And then it says find NM. Okay, so we're going to have to use Pythagorean theorem here. It's asking us to find the distance from here to here. We know that this is 8 and this is 15. So 8 squared plus 15 squared equals NM squared. So we'll just do a little bit of math. $64 plus, what's 15 squared? 225? Can someone double check my math? Alexa, what's 15 squared?
15 squared is 225.
225 plus 64 is 289. Alexa, what's the square root of 289?
The square root of 289 is 17.
Okay, so that length is 17. Okay, no questions? Moving on. PR. You know what? 7 and 8 are exactly the same as 5 and 6. So I'm not going to waste your time doing that twice. Let's just go to 9. I'm not going to write the question down because it's going to take a lot of time, but I will read it out loud. Question 9 says, a chord is 22 centimeters long. It is 60 centimeters from the center of the circle. What is the radius of the circle? All right, so whenever you have a word problem with chords, draw a sketch. We got a circle, and it says a chord is 22 centimeters long. It is 60 centimeters from the center of the circle. This is not the radius. The radius is this plus some extra, okay? We know that this is a right angle because the shortest distance from a chord to the center would be a straight line at a right angle. Okay. What is the radius of the circle? All right, so this is all the information we have, and we're looking for the radius. So what we need to find is this, the dotted line. To do that, we're going to set up a couple things. Let's break the 22 into two parts because we know this bisects. So this is 22. So really this is 11 and this is 11. Okay. So now we have
11
Oh, wait. I don't know these are 11s. Okay, that's where I made a mistake, I think. Yeah. We don't know that those are 11. We'll just call this whole thing 22 still. Is that going to help me? No. Oh, yeah. Hang on a second. If I do this, I know that that's 60. So if I do these two in a Pythagorean theorem, I can find this. And then if I know this, how does that help me find this? I'm missing something here. Maybe I read something off. A chord is 22 centimeters long. It is 60 centimeters from the center of the circle. What is the radius of the circle? Oh, I don't know that this is 60. I'm sorry. Yeah, that's not 60 is not the radius. Okay. So I was right the first time. That's 11. How does that help me find this? Oh, duh. Okay, I got it. It's simple. Well, it's not simple, but okay. So do we all agree that this is the radius here? Okay. If this is the radius, we all agree that this is also the radius here, right? Correct? Yeah. So what we're going to do is, if we find this length, we can use that to find x. So we just need to find this length. So I was right the first time. This is actually 11 and 11. So we need to find the radius. And that's what we're trying to find, right? So this is a triangle. 11 squared plus 60 squared equals the radius squared. Okay. That's 121 plus 3600 equals r squared. This is 3721 equals r squared. Alexa, what's the square root of 3? Alexa, what's the
square root of 3 is 1.7329.
Alexa, what's the square root of 3,721?
The square root of 3,721 is 61.
61. So the radius is 61. Okay. Now the problem might ask you to find this distance. So this distance is 1 because this is 60. You just subtract it to get that. But it's not asking for that. It's asking for the radius, which is 61. Okay. Sorry, I got a little confused there. How are we doing? We okay? Okay. Some of these problems are going to do that to you. You're really going to have to think about what you're finding and what you have. See, I was moving too quickly through that and I forgot exactly what I was trying to find. Okay, let's look at number 10. And these are going to get progressively harder. 10, 11, 12, and 13. All right. What's my time? All right. Maybe I'll skip one. The diameter of a circle is 170 inches. The circle has 2 chords. Let me read it out loud first. The diameter of a circle is 170 inches. The circle has 2 chords of lengths 26 inches. What is the distance from each chord to the center of the circle? Circle, diameter of 170, and 2 chords that are 26 inches. This is not drawn to scale. Okay, so we're trying to find the distance from each chord to the center. So these are the same, and we're trying to find that. That's x. And we know this is 26, and this is 26. Okay. So basically what you have to do is if the diameter is 170, what is the radius? It's half of 170, right? Which would be 85. You put that into the Pythagorean theorem and you solve for this side and you've got x. So you would do, well, the chord is 26, so this is 13. So you would do 13 squared plus, we'll call it x squared equals 85 squared. Alexa, what's 13 squared?
13 squared is 169.
Alexa, what's 85 squared? Alexa, what's 85 squared?
85 squared is 7,225.
Alexa, what is 7,225 minus 169?
7,225 minus 169 is 7,056.
Alexa, what's the square root of 7,056?
The square root of 7,056 is 84.
Okay, so the distance from the center of the circle to the chord, or either chord, is 84, in this case, inches. All right. Any questions? No. All right. You guys don't like to ask questions. That's cool. All right, number 11. A chord is 16 units from the center of a circle. The radius of the circle is 20 units. What is the length of the chord? All right, this is the same problem, but instead of finding the radius in the first one, which was number 9, this one we found the distance, and then in the one we're doing now, we're just finding this here. And it's asking for the length of the chord. So let's just do this one real quick. Okay, we have a circle, and the chord is 16 units from the center of the circle. The radius of the circle is 20. What is the length of the chord? So we solve for this, double it, and we have our chord. So we'll call this x, and we're looking for this. We're looking for basically what 2x is. All right. So x squared plus 16 squared equals 20 squared. X squared plus 169 equals 400. X squared equals 231. Alexa, what's the square root of 231?
The square root of 231 is 15.1987.
Hold on. Alexa, what's 16 squared?
16 squared is 256.
That's wrong. It's 256. I was thinking of 13 squared. So that's 144. So x is 12. Okay, x is 12, but I'm looking for two x's, right? So double that and you get 24. So the chord is 24. Okay, moving on. How is the measure of the central angle and the corresponding chord related to the measure of the arc intercepted by the chord? I'm going to skip that. You guys can figure that one out. It's not hard. The answer is the measure of the central angle is equal to the measure of the arc. Yeah. All right, last one, 13. A wheel with a diameter of 25 inches is in a puddle of water 8.1 inches deep. What is the width of the wheel? It says that AB at the surface of the water. Okay, so we have double circle here. And the water is going through. And AB is here and here. All right, let me reread this. A wheel with a diameter of 25 inches is in a puddle of water 8.1 inches deep. So diameter of the wheel is 25 inches. Does that mean from here to here is 25 or from here to here? It's hard to tell from this picture. I'm guessing from outer to outer. Yeah. So really, okay, so really this circle here is just, it's kind of in your way. It's confusing. So you can erase that circle. So here's the wheel. And it is 8.1 inches deep. And the diameter of this circle is 25. Okay. So if the diameter of the circle is 25, what is... So let's just extend this up here. We'll call this x, because we don't know what it is. The diameter is 25, so we know that this is 12.5, and this is 12.5. All right. So this water is confusing. Just think of it as a chord. So now we have a similar problem to what we've done. What is the width of the wheel? Okay, so you want to go from okay. Here's how we do this, I think. If I know the radius is 12.5, I know that this is 12.5. Does that help me? It doesn't seem to. Okay. If these two lines are parallel, I can draw this line, this chord here. Right? And this is the same as X. This chord is the same as X. So I can find the length of this chord, which will tell me what X is. All right, so I'm gonna do that. I'm gonna find X basically. No. That's only if that's a right triangle. We can't do that. This is different. Maybe it's because I drew my circle crooked, I'm having trouble seeing it. Oh, yeah, I think I figured it out. Okay. The diameter is 12.5. This is also the radius, right? So this is X. So this here needs to also be 12.5, because that's the radius. So this is 12.5. What is X? Okay. So X is whatever 12.5 minus 8.1 is. Alexa, what's 12.5 minus 8.1?
12.5 minus 8.1 is 4.4.
Okay, so X is 4.4. Now we can use that information to do this. Here's the radius. This is 12.5. Now we have a right triangle. Here's our right triangle. It's 4.4 and 12.5. We solve that, and that'll tell us what this is. I can call it Y. And when we double that, we'll have AB. Are you guys still with me? My computer turned off. Are you guys still with me? Okay. Alexa, what's 4.4 squared?
4.4 squared is 19.36.
Alexa, what's 12.5 squared?
12.5 squared is 156.25.
Okay. So 4.4 squared plus y squared, which is what I called here to here, equals 12.5 squared. So subtract 156 and 19.36. Alexa, what is 156.25 minus 19.36?
156.25 minus 19.36 is 136.89.
Alexa, what's the square root of 136.89?
The square root of 136.89 is 11.7.
So y is 11.7. We're looking for the distance from A to B. So AB is double this. So Alexa, what's 11.7 times 2? Alexa, what's 11.7 times 2?
11.7 times 2 is 23.4.
There you go. That's AB. Let me double check my answer key to make sure that I got that. Yeah, 23.4 inches. Okay, so let me recap. It's a lot. I know it's a lot. This is the hardest type of problem you're going to do for this section. All right, they gave us the diameter. We cut that in half to get these. We used the diameter of 25. I'm sorry, the radius of 12.5, and we subtracted 8.1 to find this length here. Then we used this length and this new radius I drew to find the missing side here, and then I doubled this to get the total distance between A and B. All right, that's all I have for you guys. So if you gotta go, peace out. Otherwise, stay and ask questions. I'm here for another couple minutes.